Good morning, everyone. Today we are going to continue our conversation about rigid motion. And today we are going to introduce a new kind of rigid motion, which is called reflection. First, let's quickly review what we had about rigid motion. In the simple words, we know rigid motion just change the location of the figure. So we are not changing the size or the shape. That's why we call the figures are actually congruent after this kind of rigid motion. And also we mentioned the picture before the movement is called pre-image. And also the picture after the transformation or the movement we call the image. And we prefer use little comma to label this one, which is called prime. A prime, B prime, C prime. And also as I mentioned before, rigid motion has three kinds. So last lesson we talked about translation. Today we are going to focus on reflection. Let's check what reflection means. So reflection is actually a simple word is just a flip over a line. So here the keyword is flip. As you can see, this is like one of my favorite view. It's called Mirror Lake. The reason is, as you can see, the whole mountain is reflected over the lake. You can see the picture on the bottom, and also in geometry, you can see another example. This is actually the example of we reflect the triangle ABC over y-axis, over the vertical line, y-axis here. So this is what happened here. And also one thing I want to remind you is for, as we can see, this is reflection over line. So this kind of line, or since this is reflected over this kind of line, we call them line of reflection. That's basically the name to tell us how the graph reflected. And for the next video, we are going to check, not really next video, for the following part, we are going to check several examples regarding how to do the reflection. So let's check the first example. This one telling us we are going to reflect this figure across x-axis. So let's highlight the x-axis here. So x-axis is the one we are using here. This is a line here. And since we're going to reflect across x-axis, so basically you can imagine we are going to flip this picture over, so over up to the other one. So let's start doing this. First, remember, it's just like when you're looking into the mirror. And when you look at the other side, this is just we are looking for the location of the other side. So my way to do this, I'm checking how far away from each point to the line of reflection, and I count it the same way for the opposite side. For H, 1, so we know the other side is going to be 1, so this is our H prime. Whenever you finish one, make sure you label this. And for B, you may wonder where B goes. Because this is stay on the same, so we're going to use the same point because the B is on the mirror. Just like when you point a figure on the mirror, it's going to stay where they are. For A, 1, 2. So we're going to replace this 1, 2. So it's going to be here. Again, label this as A prime. For F here, it's going to be 1, 2, 3. So we're going to repeat 1, 2, 3. So this is our point here. And again, make sure you label everything clearly. Also, this is going to be AF prime. Make sure everything is labeled clearly. We know these are the points we are going to use. And then finally, we are going to use the line here. So we are going to do here and B here and H here and the last this. As you can see, we label everything clearly. If you think these little marks kind of, distract the whole point here, you can definitely erase them to make sure it's more clear for you. Okay, so that's it. Okay, now let's go back to check. Let's choose one point to see what happened to their coordinates. So for this one, as you can see, for A here is 1, 2. And for the part, so 1, 2, and 1, 2. So it's 2, -2. And if you check A prime, you will notice is 1, 2, but 1, 2, so it's up. So if you really pay attention to the coordinates, you realize the x stay the same, and the y part is actually change the sign. So let's check another point. For f here, as you can see, is -1, -2, -3. So it's -3, then -1, -2, -3. And if we check the f prime here, you will notice is -3, but it's going up, so it's +3 here. Same thing, the x stay the same, but y, you see that? Y change the sign. So if you write down the rule, we will notice when we reflect the picture across x-axis, you will realize the x will stay the same, but y will change to a negative. Also, one more thing I want to remind you, sometimes we don't call this x-axis. We can also write this as y equal to 0, because every single point here is y equal to 0. Okay, so that's one example here. Very similarly, we are going to work on this picture, but this time we are going to reflect across y-axis. You can definitely try on your own and compare your answer with mine by pausing the video here. So I just again highlight the picture here, y-axis here. We do exactly the same thing as we did here. We counted how many units away from each point. For L is 1, so this is L prime. And for G, if you worry about the marks, we can just count it. 1, 2, 3, 1, 2, 3. So this is our G prime. For Q, 1, 2, 3, 4. Then we do the same thing. 1, 2, 3, 4. So this is Q prime. Again, besides label it, we also need to connect them. So finally, we connect them, the graph, L to Q and G to F. Okay, so as you can see, this is like a flip over this vertical line here. And also, we want to pay attention to their coordinates again. So, for example, L is 1, 1, 2. So it's 1, 2. Then what happened to the L prime? So L prime stays as -1 and stay the same for 2. So as you can see, what happened this time? So x changed the sign and y stayed the same. So let's use another point to prove this conclusion. 1, 2, for Q, 1, 2, 3, 4. So it's 4 and -1. This is for Q, and same thing here. 1, 2, 3, 4. But this is on the negative side, -4, and the y stay the same, -1. So for this, whenever we cross reflect the line, the rule becomes x will change to the negative sign. As you can see, -4, 4, 1, negative, and then y stay the same. So it's actually very, very different from the one we had before. If you check this one, is y stay the opposite and x stay the same, right? So now again, for this line here, besides writing down y-axis, we can also write this as x equal to 0. Okay, let's work on our very last question here. This time is a little bit different. So as you can see, the line we need to flip over is x equal to 1. So one more thing I want to remind you, whenever x equal to a number, this is a vertical line. Because we are talking about when x equal to 1, how is this line here? And if this is y equal to something, then there's going to be a horizontal line. So please make sure this is clear. Okay, now, in order to reflect this picture, the very first thing we need to do, we need to look for where x equal to 1 here. So let's highlight the picture here. So first of all, x equal to 1, I look for the value on the x-axis, which is 1 here. So then I'm going to draw the line through this point. So this is our line of reflection. And then we do exactly the same thing as we did. We counted how far, let me write down here, x equal to 1. We how far away from this mirror. G is 1 unit away, so 1 unit to the other side, say J prime. Again, if you do not like see so many marks, you can definitely count it. 1, 2, 3, 4. Then do the same thing, 1, 2, 3, 4. So it's going to be P prime here. And you can see here, C is exactly on the same vertical position here. So we don't need to count it again. It's going to be 4 units away from this line. And also it's going to be the same position, so I know this is going to be our C prime. Now, do not forget, after label this, we also need to connect them together. So J to P, P to C, and C to G prime. Okay, so this is our final answer here. So some student might say, then what is the rule for this one? Personally, for this kind of thing, just based on the position changing, the rule can be various. So instead of memorizing this, I think you can definitely use this way to demonstrate how to reflect the picture like this way. Okay, so that's all the example I want to share with you regarding reflection. I hope this video is helpful and thank you so much for watching this. See you soon everyone, take care.